Okay, let's see the examples for sketching square root function. So example 1, let's say you have fx equals to negative square root of x minus 4 minus 1. So step number 1, we would like to identify the types of functions that we have here. So this indeed is the form that we would like to have, the form that we learn to do graph sketching, where if you do compare between the form that we learn and the example given, so the a is equals to -1, m, which is coefficient of x, is referred to +1, the constant c is -4, the k is referred to -1. And among these, the a and m is the one that important to help us to decide the shape later. So the type is done. Now we go on with the shape of the functions. So the shape of the graph, what we have is that by observing from the function, we notice that we have the coefficient of x is positive. So from positive x and negative square root, this is the one that we're going to have the clue to solve the questions, to sketch the graph, where this is corresponding to m greater than 0, a less than 0 in our functions of square roots. So how we decide the shape is that we are going to base on the shape that when the time you have positive x positive square root. So this is the shape that we have. From this shape here, we happens to do adjustment, fulfill the requirement of the question. What is required by this question here is that we would like to have the square root to be negative. So therefore, I need to do changes on the function square root. From positive, I want to change to negative. So in that case, from positive square root to change to negative, I need to flip the graph vertically, and it happens to give me the shape like this. By the time I, from positive square root, switch to negative square root, I flip vertically, and the graph will happen to shape like this now. So remember, this is the shape of the graph that we need. So we've done the step 2. Next, we go on with step 3. Step 3, we want to determine the special point. In the case of square root, the special point will happen to be the vertex. And where is the vertex? So guys and girls, the vertex is referred to the point here. This is the shape that we obtained on step 2 just now. The vertex will be located in here. And how we get the answer for the vertex is that the x coordinate, we're going to base on x minus 4 here equal to 0. So we have x equals to 4. Then the corresponding y coordinate, it will happen to be, just refer to the -1, the constant behind there. So we have y equals to -1. And therefore, I have the vertex as 4 minus 1 as the coordinate. And by right, come until step 3 here, you will find out that up to step 3 here, it's good enough for you to take notes that whether the x and y intercept, whether exists or not. And at the same time, by right, from here, you shall be able to decide what is the domain and range. By observing from these special points here, somehow we can tell that the domain of the function, it will happen to be start from x equals to 4 all the way to positive infinity. The range start from -1 all the way to negative infinity. So that is negative infinity until -1 close. So just in case you want to determine domain and range, until step 3 will be good enough. Then we proceed with our graph sketching. How are we going to base on this step 3 here to decide whether the x and y intercept exists or not? We try to do a rough sketch. Make use of the reference of the special point. And then we put in the shape of our graph just now that we have. Then from here, you find out that if this is the rough sketch of your graph, it somehow let us notice that both the x and y intercept does not exist. So we just proceed with the graph sketching. And therefore, the graph sketching that we have is just happen like this. And make sure you remember, label the x, y axis, the origin, the graph, and also the xy intercept, if let's say exists, and also the special point, in this case here is the vertex. So check, I do label I do label my XY axis. I do label the origin. I label the graph, which is the name of function f. XY intercept does not exist. And then finally, label the special point, this point here. So therefore, this is how I happens to get my answer for the example number 1 here.